Welcome to aminacademy.com. In mathematics, regarding Fourier coefficient and function, let us do some solving problem. Look at this example. Expand f of x equal x square to the limit 0 to 2 pi in a Fourier series if the period is 2 pi. And hence, prove that 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus dot 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 equal pi square by 6. Here, look at this graph. It is f of x equals the x squared function with the limit of 0 to 2 pi. This is a graph. Now, let us start the problem. Here, f of x equal to x square. The limit to 2 pi in a Fourier series if the period is 2 pi. Now, 2l equal 2 pi, which gives l equal to pi, and choosing c equal to 0, then the coefficients of Fourier series first an equal 1 over L integral c to c plus 2L f of x into cos n pi x over L dx. This is n, the coefficient of an, which is equal, L is pi, that is 1 by pi integral c0, c plus 2L is 2 pi because L is pi. F of x is x square, the function given, and also nx pi over L, because pi over L is pi, so cos nx dx integral. Now I will do the integration of x square cos nx dx. As rule, first function, that is x square, integral of second. Cos nx differentiation is sin nx over n. First function, integral of second, minus integral of differential of first, x square differential is 2x, integral of second is sin nx over n. Here, look at here, first function, integral of second minus integral of differential of first and integral of second. Further, we have to integrate this one more time. Look at here, equal x square sin nx over n minus here 2 over n will take out. Then we have x into sin nx. Here first function, integral of second, sin nx integration is minus cos nx by n. First function, integral of second, minus integral of differential of first. Differential of first is 1, and integral of second minus cos nx dx. Now further, x squared by n sin nx minus plus 2x over n square, here 2x over n square cos nx. Nx, this is out of integration. Now minus 2 over n minus is plus 2 over n here first function integral of second minus integral of differential of first integral of second. 2 over n 2 over 2x over n squared cos nx minus minus plus 2 over n. So total is minus here minus here minus here minus, so here it comes minus integral of cos nx is sine nx over n. So now we are giving the limits of 0 to 2 pi. 0 to 2 pi. The first part is 0 because here x is 0 and 2 pi sine 2 pi is 0. Here this or this also here this is cos 2 pi n, that is cos 2 pi n is this is 4 pi. This 4 pi cos of n pi is 1 by 4 pi by n square. Here the sine part is 2 pi 0, which gives 4 pi by n square. Now we'll do the coefficient of, now we'll do complete part, that's coefficient an equal 1 over pi into this here, that is 1 over pi into 4 pi over n square, which is equal 4 over pi, not 4 over n square, because pi and pi cut. We have 4 over n square where n is not equal to 0. Now we have to find a0 if n equal to 0, if n equal to 0, therefore we have an equal, that is a0, sorry, a0 equal a0, the formula is 1 over pi 0 to 2 pi first function x square dx, which gives x cubed by 3 with integral 0 to limits 2 pi, which is equal 8 pi cube by 3 pi, which is equal 8 pi squared by 3, which is a0, coefficient a0. Now bn coefficient equal integral that is 1 by L integral 0 to 0 plus C plus 2L, that is 2 pi 0 to 2 pi f of x into sine n pi x over L dx. This is equal 1 by L is 1 by pi 0 to 2 pi sine nx by L is that is 1 by pi taken out 1 by L and x square sine of nx dx. So this is a now here we have to integrate this function and applying the 1 by pi into this integration of this uv and applying the limits, we will get bn equal 1 by pi. Here first function integral of second is minus cos nx over n minus integral of differential of first and integral of second is minus sine nx over n square plus 2 one more time integral of 2x sine nx is 2 into cos nx over n cube. Therefore, the limit is 0 to 2 pi. That means previously I explained about integration by parts of this function. Same procedure you have to follow for bn, that is constant bn, using integration of x squared sine nx by using uv method. Then we have this. We apply the limits of 2.0, we get finally get bn is minus 4 pi minus 4 pi over n. Carefully applying the limits of this one, we will get this. So we got the a0, an, bn, the coefficients of Fourier series. Now we write the Fourier series. General Fourier series is like a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Here, this is a Fourier series. We have to apply the coefficient a0, an and bn, and with this series, we'll get finally the Fourier series, that is f of that is x square. F of x equal to x square here. Fourier series of f of x, that is x square, is equal finally 3 by 2 it's not related to this. Okay. 4 pi square by 3, that is a 0 plus sigma n equal to 1 to infinity, then 4 by n is 4 over n square cos nx minus 4 pi by n sin nx. This is a Fourier series for the limits 0 to x to 2 pi. Now we got a Fourier series for x square. This is a Fourier series. Then from above this question we have to find and hence prove, look at here, and hence we have to prove that the series 1 over infinite series 1 over 1 square plus 1 over 2 square 1 over 3 square plus up to infinity equal to pi squared by 6. We have to prove it. Now look at here, at x equals 0 the Fourier series at x equals 0 the Fourier series become 4 pi squared by 4 pi squared by 3 because we are using x here. Here x equals 0, cos 0 is 1, that is 4 by n square. Here sin 0 is 0, so 4 pi squared by 3 4 pi squared by 3, that is plus sigma n equal to 1 to infinity. This become 1, that is we have 4 by n square. Look at here, this become, because if you put 0 here, cos 0 is 1, here 1 into 4 over pi square, this 4 pi squared by 3, which is, but this Dirichlet condition by Dirichlet condition for series converge at x equals 0. Therefore, x is 0 to half of 0 plus 4 y square plus 2x square, that is, which is equal to y square. Therefore we can say 1 over 1 square plus 1 over 2 square plus 1 over 3 square was to equal pi square over 6, which means we are here we are giving expansion, and with this 4 pi squared by 3 we will get pi squared by 6 because it's converged, but going next terms is quickly converged. So 4 pi squared by 3 plus this, the first term, that is after expansion, the first term, we have the means put n equal to n equal to 1 means 4 by 1 square, and here therefore this will give us 5 square by 6 by using this condition. So hence the result. We have done. Please subscribe our YouTube channel.